My name is Allister Banks. I am pleasantly surprised. This is the last talk that I'm giving this year, but I'm so pleased that people come up and they say, "Hey, Allister, it's nice to meet everybody, and it's nice to be seen," as they say. But get that out of the way. I am at Sacrilegious on the Twitter. You should follow me on the Twitter. For the email, those that can be people of the email persuasion. I have the shortest domain, abanks@318.com is the work one. We're headquartered on the West Coast in Santa Monica. I'm from the New York office. We're here, we're there, we're everywhere. 318. And you can also email me, al@aru-b.com, where I also have a Tumblr site, if only I had been acquired by Yahoo for $1.1 billion. So I guess I'm up in front of everybody with the microphone that's doubled up, and therefore I can do kind of strange things with the acoustics, because I'm somewhat acronym compliant. I am halfway to my CCNA. I took all the certifications that are given by a particularly cool wireless access point company, not inexpensive, called AeroHive. And if you don't use either of that gear, you might kind of think, well, what does this guy know? He only knows the proprietary systems that they're talking about. I just consider myself somewhere around an advanced beginner, and when you're starting out and you kind of have made sense of some things, maybe that's the type of person you would like to learn from. After that PKI talk in here that Tim Perfect gave, it's going to sound, well, here we're going to go. So, that's kind of why I'm here giving this talk, is because I actually wanted to learn a little more about it. You don't care about those standards or those vendors, that's all right. I still think that we're going to be able to get something out of it, because the frustrations that you commonly face, it does not matter. We all get on networks at some point. We all need to figure out at least the basics of subsistence troubleshooting. I did in my bash history, I did a sort and unique, right? And the number one command that I ran was ping. And I was like, how do I consider myself a command line jockey if my number one command that I ran is ping? Number two was the man page for LN, really. Like, which one does go first, you know? So, we're going to try to tackle and unravel a more complex topic like networking. In the session description, I mentioned two things just as teasers to kind of hope that people are okay with listening to basics. Like, if this tickles your fancy. One is, what is a modem in comparison to a router? And in more general, we're trying to get a betterer understanding of the zeros and ones flowing over the network. Neither of which is particularly Mac-specific stuff, but we will touch on a few things later. For the networking stuff, we will stop short of VLANs and proxies, mostly because I don't interact with them too much on my day-to-day basis. Maybe it's above my pay grade. I don't know about you guys. You guys look very well-fed and groomed, and you're attractive individuals, and that's why you're here. I know that's why you're with us today. So we're going to do the modem versus router part first, and the whole picture won't necessarily come together until the very end. But it's going to be somewhat consumer-focused until then, so we can all relate about the stuff that we have in our homes. We all kind of want to know how that works. So I think the only real prerequisites you might need, you want to know what an IP address is. Everybody kind of does know that. They're going to nod their heads at least. 172.16. Where does the range end of 172.16 for local networks? Anybody know? 172.16 through 172.32. Alright, you guys are in the right place. So, the second network, 192.168, right? What's the third network of local, it's valid for using for private network? Thank you. Okay. Yay, you guys are awake. Hello. End of the day. We're gonna make it. At least I didn't go right after lunch, right? So, and the other prerequisite kind of, that DNS is at least important, and, acronyms, knowing what those mean aren't the important part, it's the essence behind it. It's the fact that a name maps to a number. That's how computers are actually finding themselves. We like to type in names because we like to find things. So in the past, I have used a question and answering widget service thing so that people don't interrupt me. Because I kind of like have a script, and you might be able to tell that, unfortunately, because I haven't practiced enough. But that way you can hold your questions until later, and then if I do cover the thing you're going to ask the question about, we don't necessarily take too much of each other's time when you just watch this. It's always on the next slide. You can hold off until Q&A. However, this time, I'm hoping that we're going to have a little more fun than that. We can be a little interactive, and it's mostly because that slide in the very beginning, well, not slide, the Twitter comment in the very beginning, that advanced beginner. So we're gonna, if you're not in here to just surf the internet, we're gonna feel each other out and try to come to a better understanding if anything I say is particularly worth interrupting for one of two reasons. One is that I'm just being too arcane, or I'm trying to sound more complex than I can actually back up with knowledge, if I'm just using buzzwords, or if there is BS detected. You can even, I encourage you, to go ahead and if you have an iOS device that has a cell signal and therefore can get to internets, there is this app. I didn't leave it unlocked on my phone, but it is like a service bell that you can ring. Instead of raising your hand and kind of waiting, because maybe you'll put your hand back down, you can ring the bell and I'll be able to find you out here. So feel free to interrupt me at any time, just about. But please have it be about topics at hand, or a topic that we covered that you're not sure relates to where we are right now. Please do mix it up. But I am into instant gratification. Let's get into that modem versus router explanation, or that comparison. The naming modem. It's a word made up of two other words, otherwise known as a portmanteau, like Wikipedia's favorite example, the spork. So the concept of a modem has to do with receiving a physical electrical pulse or analog signal over some sort of media. I'm already getting into it, so if you guys want to ring anytime, you want to buzz in, you got the right answer, you feel free. Okay, so media is the conduit, the pathway that we're taking to our box, whatever device it is, or whatever hop along the way. The media that we deal with most traditionally is copper, or fiber, or WiMAX, or the modem's job is to convert a analog signal, because it's all just about following a sine wave or a electrical wave, and then converting that into a series of zeros and ones that is interpreted by modulation and demodulation. So, the portmanteau was modem. M-O, modulation, D-E-M, demodulation. So that's that particular one. And I can explain that concept by doing the electric boogaloo. So you got a wavy over here, and you're doing pulses over here. So a metronome in the middle is going to count out time. All computers just need to count out time so that they can figure out what's going on with an electrical signal and convert that into zeros and ones. So enough dancing, fun, and excitement. You've got the concept somewhat. So the word signal in there is somewhat important because we're talking about the original communication was over telephone lines. And the audio connection is implied. The main distinguishing feature where you see the word modem used for new devices instead of the old telephone handset, or like in the movie War Games, is in the fact that there's an analog to digital conversion where the internet service provider has a signal they're sending, and for our computer to standardly interpret it, whether or not it's like a cellular dongle or something that you then tether over USB or something, the carrier's signal needs to be converted. And this stuff is actually crucially interesting to me. Like I want to rip each page out of the book, fold it up, and digest it separately. I like this book so much. Like Taposana as well. This is a book's code. It goes through the history of how computers were invented most primally and originally for signaling, for communication. And you perform math to then build up all of these, basic math, then can be built up into increasingly more ingenious concepts through which everything that we can do with computers was invented. And this goes over the entire history of that. Or, instead of reading this book, which is not a humongous tome, right? But it almost seemed the exact inspiration for Ed Marzak's presentation yesterday, that I'm somehow assuming that most of you were not there. You will want to catch that on the YouTubes. Catch it. Coming at you. If you liked his presentation, you would love this book. Without getting into the mathematical rabbit hole behind networking in general, he goes over stuff like bits versus bytes. Those pulses that my left arm were doing right back there, that's actually another portmanteau. What was being emitted, essentially, was another portmanteau. Binary digit is bit. So that's where I learned that from this book. Binary digit, bit. So that's what that piece of data, how that was named. So let's get back to routers in comparison to a modem, which is conceptually similar. I'm a big fan of Bosch as tools go. It's pretty damn awesome. A router is simply a pointer from one network segment to another. That's it. End of story. You're all free to go. I'll turn around if you want to go see the other sessions. No. Whether or not you're going from a local network to somewhere outside, there's not any physical carrier signal conversion. There's just that it's aware of IP addresses, and it can be bundled into the modem. They're usually both found where our network, air quotes, physically meets the internet. And just to get sidetracked having fun about terminology, you know how Apple doesn't refer to these as laptops because you're not really supposed to place them on your lab, and the urban myth is that people got burned and there was lawsuits, and so like, notebook, no, it's a notebook computer. Well, I also am hung up on terminology, and so I don't like talking about systems, right, in the plural, when it comes to the things that I administrate. It's all connected, it's one thing in the singular. I even look at like job adverts where it says system administrators. Actually, there's just one system, or systems administrator. And here's a more eloquent diatribe on that particular hang-up. Sorry that this isn't necessarily directly networking related, but there is one system, not a collection of systems. The desired state of the system should be a known quantity. We're doing a sound check right now. So you can go to this URL. I do not need to read this guy's entire missive or diatribe out to you, but I do quote it somewhat often. So we talk about our local area network, our LAN, as one of many. You know, what good is a computer that can't talk to the internet? We are all painfully aware of lack of wireless makes for an unhappy camper. So all a router is doing, it isn't necessarily involved in the minutiae of decoding signals. It's more about making handoffs and finding paths. Routers functionally also understand IP addresses, which sometimes folks who want to customize their home networks will take that IP addressing responsibility back from the combo modem, router, wireless, Westel, box of crazy talk that they get from their ISP internet service provider like Time Warner, Verizon, Comcast, Cox. To summarize, routers have a specific technical purpose, whereas modems may integrate that functionality, but are often named such due to the media or type of service or cabling that feeds directly into them, that's plugged directly into the back of them. For example, phone lines, DSL modem, coax, routers are more generic. I think we can leave modems behind for the rest of the talk. Any questions about modems versus routers? You guys are very interactive. I really like you staying with me through the end of the day. But okay, I guess that means I can move on. So, now we have the internet on our doorstep, and the on-ramp to the information superhighway is in place. I don't think I could say anything more cheesier in any of my presentations today. Let's talk about splitting up that connection at the most basic level, cabling. And in particular, we'll talk about the gear that is often an integrated component of that router. Hopefully many of you weren't around for the Great War of '96, switch versus hub. Really, I'm sure that there's still places that are still having that war, but let's assume that we were all born yesterday, and I'll just let out my pain and agony on you. So, There are a bunch of ways hubs sucked, but also history lessons suck. So let's just talk about the problem that switches solved, and we'll actually be answering our initial question of how the zeros and ones actually most initially get over the network. So, there are commonly two kinds of switches. We've moved on to switching from our initial talk about, where the internet comes in. And you may have not all dealt with the more expensive kind, which are referred to as smart or managed. Both kinds have logic going on in them. They are not, to use an electrical analogy, like a cube tap. Like that's the most basic way that you split up a electrical connection, right? Or like a surge protector. There's no real logic going on about what's plugged in where, unless it's supposed to be green and it's all branded or whatever. Each individual port on a switch, meaning the place that you plug in your cable, becomes aware of the device on the other end. Whether it's a server, an uninterrupted power supply, it's like I'm telling myself limericks, a laptop or a desktop, or a godforsaken printer. What does it know about that device, and how? Well, when the device tries to become a full-fledged member of the network, and able to send and receive bits, it needs to get an identifier that's somewhat hard-coded, recognized about it, and spread out to everybody else on that network. And that's its MAC address. That MAC address dies at the router. That is the border at which we're talking with our MAC address out. And that's media access control is what MAC stands for. It's a series of characters that every network communication device uses, theoretically globally, and for all time, even though that's really not going to last, and I'm assuming that some vendors do rotate it over time per model. It's still there to, in essence, uniquely identify itself with some amount of accuracy. So, to bring it back to hubs, they were so dumb. Hi. They never learned anything about anyone and ended up broadcasting everything, everywhere, every time one node or point that could be talked to wanted to communicate to another. One device wanted to send a message to another. So, here's analogy time. Yay, this is going to be really interesting because you've never heard analogies regarding networking. So there's a no-charge toll, right? With lanes fed by separate roads that are two-way. You can go either way through this toll. And on the other side of the gate, you can switch lanes and go back through, okay? Before a tunnel. There's one tunnel, there's multiple roads fed into a toll, okay? No fee, but a switch allows for transmission to hop on the other side of the toll and go back through whichever road. And it also governs where you can get back to. It understands what that port means, what that gateway that you're going through means. Whereas, a hub, you got like an idiot paperboy on a cul-de-sac, on a, like the dead end at the end of a street that goes in a circle, and he just flings stuff at every house because he doesn't recognize them, he doesn't really care what it is. You get a packet, and you get a packet, and look under your chairs. So, it doesn't really care who's who. Now, even with a switch, if it's too cheap to prevent certain failure scenarios, Belkin, you could do what's called loop a network, where the cleaning person sees a cable unplugged, they think they knocked it out when they were sweeping, and they say, oh, I gotta put that back. Plugs it into the same switch. Then, the entire network essentially thinks it's also on the other side of that cable. And everything can go haywire. It's just like, you don't think that it's humanly possible to happen anymore. So, thank you, Belkin, for defying the odds. I do appreciate that. So it needs to police itself. The switches are usually that smart that they can do that. You'll just run into certain things as you get out there in the wild. You kids, stay safe. It's like Hill Street Blues. What was the one? It was like, be safe out there. Be careful out there. There you go. Thank you. You sounded a lot more convincing than I did. So still, The switches are usually intelligent about keeping track of the MAC addresses that it needs to return responses to so it can send data to and from the device. But even so, it's the first time you wake up, you're newly born on a network. You're going to say, oh, okay, there's going to be something sent to me, I'm expecting a response, right? But the switch, for whatever reason, it's forgotten about your MAC address because it has a finite amount of MAC addresses that it can keep in the table. Well, if it doesn't see anybody, it's just going to broadcast once and then shut up to say, okay, who's the owner of this packet intended for MAC address, blah, blah. So that is the return trip, just in case, for whatever reason, its clock gets cleaned. And if we're only talking about a few devices talking in a way they all know about each other, a router is not actually necessary. It is not needed to police, just communication between them, because as long as they're nodes on a switch, they can have that type of connection with just MAC addresses. And you would set manually information to be able to do that, unless you're using Bonjour, which we'll get to at the very end. You would set that in the network pane, surprise, surprise, system preferences, or sysprefs, I'm going to be referring to it. So, as a side note, you may hear terminology used for a smart managed switch versus something that can't be assigned an IP address. Something about that being the difference between layer 3 and layer 2, besides the layer 3 being on average $400 more expensive. I mean, there's a whole model chart, 7-layer cake, which I will touch on, the important parts of it at the very end, according to me, but I'm the one who has a microphone. But when you're starting out, you only really need to concentrate on the first 3. The physical, layer 1, lots of people talk about, it was a layer 1 issue. You can sound cool if you say that. Is it plugged in? Have you tried turning it off and back on again? Layer 2 is where MAC addresses and advanced features of Wi-Fi and VLANs, which again, I won't be covering too much, operate. And layer 3 is IP addresses. So really, why did the mother swan keep losing her chicks, right? Because she could only count to 3. It's just, we start with those 3, we know about them, we integrate that, and we can move on from here. But manual interaction with networking, just like I was talking about for no router required, you can manually set some things up. That doesn't sound very scalable. It doesn't sound like fun. Being without internet is a particularly big annoyance. When things change, you want to dynamically be able to go around them. So it's also not the stuff you see in sysprefs most often, right? You see stuff like DHCP, which stands for Dynamic Host Configuration Protocol. So a protocol means like the rules of the game, the rules of engagement, to kind of take a military term, right? The protocol, the straw boss is, these are how these things are going to be talking. It just defines the method of interaction. So what DHCP does is it, on the fly, helps a host, which is another way to refer to a device or a node on a network, a computer or a laptop, an iPhone, get on the network and talk. It also lets a process happen on demand so that the host can inherit a configuration. And that config we're interested in inheriting is most primarily, an IP address. It needs to get on the network. A IP Internet Protocol address. Again, that word protocol. But let's jump in with both feet into the rest of the settings you see here. There's the Subnet Mask. There's the router, which is also referred to, depending on the interface you're looking at, as the gateway. There's the DNS servers, or domain name system servers. Possibly along with a search domain. If you don't need it, it won't be there. If it's not configured to be handed to you, it won't. Certain network devices can only hand out 2 DNS servers. There's lots of different things depending on the environment. So there are now 2 subtly different ways that DHCP as a service to push down these configurations to be inherited can be implemented for any particular environment you're plugging into. Either the same server, just like an OS that's running a server OS, you could administrate for other purposes like file sharing. You could set it up or to be a DHCP server, or a hardware appliance can instead be configured and delegated that role. In either case, what's known as a pool is allotted to say, after I've been allowed into the network, after I've done the correct amount of handshakes, and there's no real secret code or secret knock or haircut you have to get into this club, they'll just give you an IP address the moment you plug in, and as long as everything is hunky-dory. And it says, okay, you can be on my network. You're plugged in this particular place, either by connecting to this particular SSID or other things. I'm going to give you the next available address in a particular pool. And I will make sure that range will be what you get handed so that you can access other things within there. When the DHCP service is running to hand stuff out, the DHCP server says, I'll show you, Mr. Host, how to find your way beyond the local network. To say, the internet, by telling you where your router is, and I'll let you know when you'd be better off finding other local hosts on the same network without even bothering the router, because again, a router is not necessarily needed to point these communications back into the network. But now there's a subdivision locally from the greater network, or another portmanteau. I'm all portmanteau all the time now that I don't know how to pronounce it. Subnet, right? Subnetwork. A subdivision of the network that you can see. So they call that the Subnet Mask. As a normal costume party mask, you're revealing only as much as you want to show. You're only blocking off as much as is necessary to allow other clients who are in the pool to see each other. I mean, really, you don't need to worry about the numerology behind it or the astrology. You set up a subnet mask because you're going to only allow, with your DHCP pool, enough clients to be on the same subnetwork, and you want them to be able to see each other based on that mask. Then how much is shown is where the 255s are, is where it's blocked. So you'll see a /24's classless internet domain routing math. Somebody was supposed to hit a bell right then. I'm disappointed. Okay, I'll make you all stay late. So let's move on. All of this can seem kind of dry, but so this is actually where my firewall at home, I've configured DHCP servers, and I've even said, for certain MAC addresses, I'm going to configure a static IP address. I don't know exactly why that, but all you need to pay attention to is the fact that you're going from a certain number with a range to a certain number. That is a DHCP pool. So, for a quick departure, let's discuss why Windows folks want to use their Windows server for DHCP, and why that usually ends up sucking for us. The last two things in that syspref view are DNS server and search domain. Windows admins want to be able to dynamically find hosts by their assigned host name, so that when you call up the help desk, hey, just tell me, don't read off a number to me, just tell me what your computer name is, because first I'll know what the rest of it is. There'll be a very small identifier I actually need to hear before I can try to make this connection to your machine. And then when the Windows server is doing that handout, they can be only semi-guaranteed to be able to find that host. Windows servers don't update certain DNS records for Macs properly when they're communicating, or more like when you're on the server and you're on the client and you've done that network stack, things are a little bit easier to control about making sure that actually works. And when it's a Mac that's trying to have that arrangement configured for it, not so much. In practice. So I'm sure that there's people that have tuned their dynamic DNS settings and it's just great. It's the bee's knees. Not the most common of stuff. So, what's more common, we end up with the pointer going to a old DHCP address, and when the help desk tries to connect to it, either the host is no longer there, or worse, you get tickled that like, hey, you're supposed to have another name, a name of another host, and it gets very confusing. I also personally like it when the networking team guarantees instead the appliances that they are going to support, because then I've delegated the responsibility to the networking team of making sure that DHCP is handed out properly and it's pointing to the correct host. I mean, we need to perform other functions anyway. You get DHCP for free from a lot of networking gear, and you don't necessarily require as much dynamic naming in certain environments. Of course, I talked about statically assigning IP addresses, which is a nice fail-safe if something loses its manual assignment, except with things like Thunderbolt adapters, because that has a MAC address, but it can be shared among multiple devices. So it wasn't a particularly, even doing static assignment by MAC address, you can kind of mess with the system. So as part of the DHCP protocol handing out settings, it also helps you do the name-to-number lookups by pointing you at your DNS service. We can, of course, either run that internally or look straight outside, but if we want to set up our own named domain to build up a hostname from, like mini.private, is an example that you'll see in Apple's OS X server setup. We'd like to not have to type private every time, and that's where the search domain comes in. Telling the client that if it just looks for mini, the network can interpret that as mini.private and send the composited, the two ends put together, when it's doing a DNS lookup. Alright, so that got a bit complex, but I'm just finding the same slots. This sign actually says, "No, that is not a gun." I have no idea what Wikipedia was doing posting this photo, but I wanted to, say there's lots of slots on a network, right? I'm still talking about the high-level, complex, how it's made, or unfortunately how the sausage is made parts. But I use the terms manual and static in close proximity. I'm sorry. Everyone is okay so far? Okay. Trying to keep it going. Okay. A lot of mind-numbingly basic stuff. Okay. Let me just finish off this one last hardware definitions before we move on to more practical Mac-focused questions. So, firewalls. We've done where the internet connection comes in, what that box is called. The fact that we need a pointer to get from inside to outside. Where all those settings are on our computer. What we talk through, and therefore we can find stuff, even without that router. These are all of the building blocks that we have underneath what's going on when we're browsing Facebook. So firewalls are all about the fact that computers need to allow communication by a process of listening and sending with a systematic division of its main channel of communication, meaning its IP address, the main pipe that it's going through. And our IP address is a portal through which we are seen on the network, but the machine is sending all sorts of messages, even without a valid address, and expecting to have that routed out and back properly. A simple example may be that we can do an SSH session. As long as that is open, you can have that running at the same time as a web browser is open. So you're making a request over port 80 most commonly, or as we saw in the last session, like 443, 465 if you're doing mail servers. So standards have been agreed upon when it comes to those numbers, and those are called ports. One connection, one message distribution hub that is the network interface on your computer, of which you have multiple, that can handle these messages to get sent out, and you're going to govern the fact that they're going to be returned to a specific slot. So I'm making an analog or another analogy between a port and just a slot on an interface. So just like you can have that same page request on the server end, all of these people might want to get the same web page, but there's a process through which it governs, okay, I'm going to take these requests coming in, I'm going to know how to route those back out by assigning a port number as part of that transmission. So, just like DHCP servers, firewalls can be implemented in software or hardware. You can have an appliance. When was I talking about they'll sell you an appliance for anything? So, it makes decisions based on ports and IP addresses most critically. That's why you buy it. That's why you turn it on and plug it in and configure it with settings. It's you want it to look at your ports and you wanted to say traffic yes or traffic no in Russia, which is, you want to block all, by default, quote-unquote, incoming connections, because it's like the mechanism by which sandboxing, if people are familiar with like PowerBox or like the frameworks underneath Mac OS X now as a mountain lion, where you're describing your intent to go open a file. You don't want any application running rampant on your entire system, so the developer has to say, okay, I'm going to allow this intent to go through, and then I'm allowed to view that part of the operating system. So the OS lets the application you're running view a file, for example. Firewalls interpret the concept of an established connection. Therefore, once it sees that, yes, you talk to some place that you're valid to be able to talk to, you initiated that connection, the firewall doesn't block it from that point forward. So that's how, when they say that firewalls block all incoming connections, you get responses back. Like, that was like a critical question to me. It's like, they say that it's really blocking all incoming connections. This is how that works. Firewall does logic to say, you established a connection. I see that in the packet that you sent. You're free to continue talking from that point forward. So firewall appliances commonly are advanced routers, meaning they have lots of other useful features, including the fact that they make a decision based on IP addresses or a MAC address. For example, you can do bandwidth shaping. You can decide, okay, that IP and that MAC address over there, I'm going to guarantee it however many %. I have to define how fast the internet connection is supposed to be, but then I'm going to allow that to go through because I'm a firewall that wants to, govern all traffic, not just do pointing in between here and there. When you're outside an organization's local network, if there are services that should be accessible because they can perform well over the internet, you're going to first make a connection to the internet, and then you're going to dial in, you're going to dial back to the home office. A secure connection can be established with what's called a virtual private network, or VPN. This is all scintillating, isn't it? A hardware appliance, again, can be set up. Sometimes a firewall will do quadruple duty for that. Or a server, again, in software, with a standard directory service backing it, so you can keep your authentication in the same place as where you're making the VPN connection through. I don't think that that's particularly vital when you can just have the firewall or whatever's acting as the VPN gateway appliance call to your directory service. That just offloads that overhead from that server. You might be noticing a theme here. After they're allowed in, DHCP takes over just like normal. And it gives them a lease, an IP address with a certain confined time period, which you'll have on the local network as well, just so it knows that it can free it up after a certain time, so that pool doesn't deplete until it's empty, and then no playing for children. There's a slightly more advanced topic after you VPN in, called split tunnels. So it's a tunnel that you're going through in the first place to connect through to the network, so that all of your communication to that local network is secure. Well, maybe you don't want a BitTorrent over that, because then you're taking down the internet connection of the office you're connecting to, because you're shoving a lot of bits through it. So, wherever you're making that VPN connection to, you can say, for every other connection that's outside of this, because I know where to point to, I know where you're looking for, I'm just going to let you talk to the internet directly. Don't worry about going through me. And the VPN works by creating another virtual network interface on your computer for you to connect through, and it knows to send the other requests by how the VPN is configured through your regular internet connection and regular network interface. So it's like an SSH connection when you're going through this tunnel, that it's considered unsnoopable, undivertible. You can't, take the packets off the line and do anything with them. Yes, sir. It can be configured. It can be configured either way. There are clients that do not get that configuration because it was not set as part of that VPN profile or VPN collection of settings that when this is live and established, a connection back to the home office, you won't have that as part of that network interface's collection of settings. I should always make every DNS request first through the home office. And that's something that comes up when... I wasn't going to talk about proxies. When you have a global proxy on an iOS device and you want to intercept all of the traffic through the device to make sure it's clean, well, if you send all of that through the home office and then this needs to download an iOS update, it might take a little while for your home office to do anything at that point forward, as it downloads 890 megs per device times however many devices you have. That's why there's better alternatives to stuff like that. Does that meet approval? Cool. Anybody else? You too can download the Service Bell app. All right. So now at this point of the presentation, I'm out of energy, so I'm going to talk entirely with an English accent. The last topic I'll be mentioning just briefly enough to say I talked about it at all is Wi-Fi. And this is SoftBank in the UK, and now in Japan, you can use Wi-Fi, tsukaimasu. So I really should have made more slides to make this an interesting presentation. A common point of confusion for people when it comes to setting up a home network is how little you can optionally do with a wireless access point or base station. They can often be routers for your network if you need that functionality. But often people are too lazy. They just let the internet service provider give all of the IP addresses on the network. And it goes into what's called transparent or bridge mode. The Wi-Fi base station is not doing anything except just passing stuff through. It allows the DHCP request to come from wherever the router is. The router will also be acting as the DHCP server in that particular scenario. Now, bridge mode, the term for switches originally, history, right? But it was originally called a bridge. The device that then ended up normally being called a switch was actually a bridge, as history goes. Now, there are two modern developments regarding Wi-Fi. One is the addition of a separate piece of hardware called a controller. And later, that controller logic was pushed out to the wireless base station itself. So first you had this appliance to coordinate activities between Wi-Fi base stations, and then it mutated in a way that they decided, why don't we take the stuff we're doing with that controller and push it out through the network so that the wireless access points kind of take care of that themselves. Now, the point of a Wi-Fi controller having a central station for the wireless access points to speak through is that you want them to have a presence during the authentication process to validate access, because rather than having to, locally on a wireless access point configure it however many times, you want to just set it once and have it be inherited across a bunch of WAPs for wireless access points. You may also want to encourage sign up of guests or agreement to terms and conditions at a splash screen when you get on the Wi-Fi. That can also be provided by a controller. And there's some environments, like not all of us at home, that have a unchanging single password for their Wi-Fi, except for Mike Boylan, who also does MAC address static restrictions to get on his network, because nobody can spoof a MAC address. If you're, for example, worried about bandwidth usage of your guests, or you just don't worry about them accessing your back of house network, your servers, looking at how many hosts are on your network, possibly setting up their own DHCP servers, possibly hijacking the clients. Maybe that's a big deal. It really starts with policy. Isn't that what we like to say? It starts with policy. What you have decided to support for your clients, how much restriction or security you need for a particular network based on those requirements. So, I think that covers the absolute minimum of standard stuff about networking that newbies might need to know or want to know about the common moving parts and how they interoperate. So let's get into some answerable or less defined questions about networking, starting with an interesting theoretical question. And this is kind of like a Nate Walk, R. Trouton question. Why don't you serve DNS from the router? Okay, so the router can be a DHCP server. Why don't we serve all of the stuff that's in that networking pane from one device? Like, we already do a lot of the other things. Now, my current favorite reasoning behind why most firewall and router vendors don't decide to do that, it's the referral process by which DNS operates. So, you saw the DNS session with Mike where he, with style and finesse, showed you that there's upstream servers that are actually authoritative. They literally say, oh yes, I'm authoritative for this zone. I will tell you exactly where that host is. You, at that point, are trusting all of the responses about that zone they say that they're authoritative for. As long as they, vouch for themselves by doing a strict process of telling you that they're authoritative. It's equivalent to your web browser kind of running untrusted code, but it's everything that you're pointed to. So perhaps routers and firewalls, they don't want to necessarily be responsible for also, no matter how static or unchanging that information might be, for the host on a local network that you're setting up a DNS server for, just to be able to do that easy names to numbers translation, maybe being socially engineered by phishing attacks. It's not something that they want to enable right off the bat. Yes, enthusiasts find running a DNS server on the router a way to offload that function from having to run a server with some flavor of bind or power DNS or another DNS server distribution. Since that information is pretty static, they can just put that in there once. You can flash certain models of consumer and prosumer. I mean, if it's less than $200, I don't know about calling it prosumer. But if it's running Broadcom chipsets, there's names of things like a DDWRT and Tomato that you can put on like Linksys. Really, it's the Broadcom chipset underneath. That was too geeky. So, I mean, just like Apple gets around to patching their implementation of bind, they get around to it. Get around to updating rsync one of these years. Extensions to the DNS spec and standard that say, hey, there are ways to make sure that we can actually even validate that a DNS response is authoritative. So, how does AirDrop work? It sets up a Wi-Fi ad hoc network for the purposes of file sharing, right? Does that sound like a reasonable definition? Yes? Yes. With a hack, it can even be enabled over Ethernet. Wait a second. So I said ad hoc Wi-Fi network, right? So for the purposes of file sharing, what does that have to do with Ethernet? So when you're using it, it's less about the network discovery, that you're setting up your own network just to do an ad hoc talk between two devices. That's what ad hoc means. It means like, made up on demand to serve like one specific purpose. When on Ethernet, you're really just using it for the authentication handshake. Like, hey, are we close by? Okay, you're good. Like that's the authentication handshake in a nutshell, but that connection for discovery is made by Bonjour. I'll get to it. So, taking a step back, how does Bonjour, ne rendezvous, work? Is it proprietary? Does it exist on Windows or elsewhere? Yes? No? How many people say Bonjour exists on other platforms besides the Mac? You're all right. Everyone's a winner. So, Bonjour is a standard. It's ratified in 2003, hot off the press. It was actually, submitted for ratification in 99. It's for governing the dynamic configuration of devices from the beginning with a link local address. So, they can still talk with host names on networks. That's the end result that you want to get to with Bonjour. You don't want to actually deal with addresses, IP addresses at all. You want to just say, okay, there's a name over there and I'm going to be able to find it. Names are friendly. So then working backwards, what's link local? So that's if you don't have a DHCP server, but you can tell that there's something collecting MAC addresses over there, you probably can talk to it. If you don't receive a DHCP server after a certain amount of time, you will assign yourself, and by you I mean your computers, because we're all robots. You will assign yourself a number which starts with 169. That is a link local address. The second part of that number will start in the 200 range. Most often. I was expecting a bell to ding just then. So as part of the Bonjour, or zero conf, which is what they called it when they were ratifying, as part of that spec, there are two other parts, besides making sure that nobody else has the link local address on that particular local network. Number one, with multicast, meaning one-to-many transmissions, you send requests so that you can find devices by host name without a DNS server. So if they put feelers out that say, hey, you can find me by a name according to the spec called zeroconf, more generically, okay, I'll be able to then find you at that name from now on. So you multicast that out to say like, hey, give me some results about your names. And you get that response back. Number two is you can tell specific services apart. It's another part of the standard, like a printer, apart from an Apple TV. So that's also called service discovery, or DNS-SD for service discovery. By the way, there is Avahi to enable Bonjour on Linux, and Apple makes installers for Windows as well. They've actually been maintaining that somewhat. I think they had to because it stopped working around Windows 7, and they came out with a new one. They're very Trojan horsey on the Windows platform. Yeah, you want QuickTime. You really do. Another fun note is that the sleep proxy service introduced during 10.6, which is how you can do some semblance of wake on LAN. So I'm asleep, but I can be listening for a magic packet, like literally magic beans that you're going to grow a beanstalk out of your computer. Once that magic packet has been sent to an interface, it will know to wake up. So that sleep proxy also utilizes Bonjour. It's specifically for wireless, and it was, of course, supported on Apple wireless hardware. It's probably a standard that's made its way into most others, but it's only newly supported by the operating system as of 10.6. So, moving along. More Mac-specific stuff. Okay, so, why is the .local domain kryptonite for us? What did the consortium of vendors, including Microsoft, that ratified the zeroconf spec, agree upon to use for the domain name that all of these hosts would have appended to them? Yes, .local. It's .com. Nobody's getting my Homestar Runner references, are they? It's okay, you know. So, where the heck was I? So, way back in 2003, using single labeled names or unregistered suffixes, such as .local, is not recommended. Yet, it shows up on all of their other internal setup documentation as the example. They have since switched to way more rolling off the tongue domains like Contoso and Fabricam, which is my personal favorite. Fabricam. I actually had a Schuler client, Fabricam. So, where the hell was I? So, when a computer wants to send a message to something it assumes is a Bonjour host, it needs to know that instead of using multicast, because .local is at the end, it's going to instead unicast, or just send to one host, its particular request for information across the network. And it will assume that it's talking to an IP address, or really just anything that it can link to over that local switch that it's talking through, or switches. Now, the DNS plumbing in Macs has been overhauled multiple times. Anybody remember lookup D? Yeah. yeah, good times. And when you disabled Bonjour in earlier versions of the operating system and all of your networking services stopped working, that was really great times because they wanted it to be that critical so that things would just work. So if you stopped it from flooding your network with Bonjour requests or getting to the wrong place on the network because you were looking for a unicast host, everything else would stop working. It's very convenient. So they've worked over that. They've worked around that incorrectly broadcasting or looking for broadcasts and communicating with hosts that have a .local domain appended to the end. I actually timed this okay. We're going to wrap up now. Yeah. All right. So rehearsing actually pays off sometimes. Hopefully, we're starting, to get the whole picture together and at least kind of be able to sort stuff out for ourselves as if this wasn't, for the majority of some of us, painfully obvious. A quick wrap up before we get to Q&A. Okay, so modems most often hand off a carrier signal from an internet service provider and convert it to digital. Routers sit between the border between networks and they help create paths. First, what do you yell for Penn State football? Anything? We are Penn State. It's a very nobody knows the anime One Piece, do you? Because he kept talking about the world government before, and we are is like a big thing that happens. Okay, so modems, it's just a handoff. Okay, you got an analog signal, you're handing it off to a digital signal. A router is just about making a path and being a gateway. You're knowing how to get from one place to another. Switches, here MAC addresses, and devices, when devices are sending information, it gets it on the send. And if it doesn't know where to route it back, it floods all the ports on the switches, is how it's referred to, and then it is able to find it. The network stack layers, I had said that it wasn't too important, but I'm still going to cover it, that the ones that we commonly interact with. One, we have the physical connections like copper or Ethernet / fiber / coax or radio waves for Wi-Fi. Two, where the MAC addresses actually live and more complicated information like VLAN tagging happens. Three is where IP addresses are, and since we're in wrap-up mode, it might be nice to also talk about, okay, so there's transmission control protocol. That's the TCP and TCP IP. That's what you're using most often, versus when you're talking about DNS requests that's actually sent with UDP. The knock-knock joke about, hey, what did you say in response to the UDP packet? That's the end of the joke, I think. Response, I didn't hear it. Yes? Can you ding? Can you actually tell that joke properly? Oh, no, the end of the answer to that question was ding. Okay, so they don't care if you get it. Thank you. So vindicated. For posterity, we have an actual rendering of that joke. I do appreciate it. So, skipping up the stack, up to 7, that's where DNS actually lives, is up at 7. I don't know why, SSL is important enough to be down below there. There's, it's somewhat weird. S-MIME, I think, is below this. So it's underscoring these other services, which almost kind of makes sense. And then there's DHCP, right? Speaking of DHCP, it gets inherited after seeking out and successfully talking to either a router that has that service configured on it, or a server, or any other network appliance or device that has that running on it. And it lets it know what IP it should have on the network, where the boundaries are, how much it can see of the network when it comes to a host that it should be able to directly connect to, or it's physically blocked or figuratively blocked by the subnet mask, where the router is, which DNS server it should use for the name to number conversion, what domain name it might want to tag on. Again, Bonjour is using .local. And link local, I had talked about, I'm referring to that number with the 169 in the front of it when you're connected to network gear, but for whatever reason the DHCP server just doesn't get to you yet. Or when you connect to AT&T Wi-Fi. and it's a day that ends in day. Bonjour can take over and allow discovery of services and host names, so you can do a good amount of communication without the rest of the infrastructure. I mean, it just works, right? So, with that, thank you very much. You guys have questions? Any questions? Anything that was missing? I came to... Yes, sir. IP helpers? Yeah. So, Pokemon, I choose you. So, there is an environment I know of in which they use multicast for imaging. They have, and multicast lives in a different IP range and zone. We talked about for the locals range that you have 172, 172.16 through 32, 192.168. Blah blah blah, or 10. Whatever, right? Multicast is like 2 something something. And when you want to have multiple subnets all be able to listen to that stream of packets and make the requests of BDSP, like if you want that packets to be routed correctly across those subnets, it might be similar to the way that Bonjour is allowed to be broadcast across subnets, but I'm not 100% certain of the implementation. Can you tell me? No, you can't?
I don't know the details. I know that we use multicast ASR for imaging, and we use a Cisco multicast rendezvous point, so all of the traffic goes there, and then all of it back to the...
So there needs to be some sort of middleman. And you can either do that on a device that knows about all of your subnets, or you have a device that those specific requests, those specific packets can get forwarded to, and not necessarily filtered out, but there may be routing involved. There may or may not be routing involved. Stand back, I'm doing science. The Bonjour add-ons that you can do, by the way, like, again, it may not be important to people that this is how Aerohive does it, and therefore it's the way that I know. It essentially, the way that a switch knows about MAC addresses. It sits there and it builds a table when you start sending. It is not routing beyond the fact that after you make a connection, it can then find stuff to route back to you. So there aren't IP addresses involved, but for Bonjour across subnets, which certain people need for like Apple TVs, to be able to, I'm on the student VLAN, but I need to be able to get to the Apple TV that's on the management VLAN, or whatever the heck they call it. And again, I wasn't going to talk about VLANs. You can set up a device that will listen for all of these requests over all of the VLANs. Or subnetworks, really, because that's really more critically what the heck is going on here. And say, okay, I built up a table, I can be authoritative for letting these packets get routed back through. I don't care necessarily about its IP address. Something was flooded, I will have that flood respond. So it's on that specific packet basis. It's not necessarily about IP addressing is the finer point of it. But where you configure that for things like netboot is with IP helpers or an appliance, a destination that can see that information in the first place and know where to route it through. Or netboot specifically?
Yeah.
Right, I mean, like... Because it can't... Well, possibly, theoretically, there is a device that can receive all of those IP helpers being pointed at the same IP. Instead of it saying, okay, I definitely need to find where the netboot server is, and I need to make sure that traffic is allowed. Instead, you kind of offload that processing to another appliance that does that connection for you and make sure that everything is allowed, or that you're defining that policy elsewhere. Yes, sir?
So, do you use an IP helper to locate network time machine?
Network time machine volumes. So a authoritative maybe. Rock and roll. Yes, sir. Yeah, my favorite story from early 10.6, early 10.6 was IPv6 was new on the scene, and it made all DNS requests through both IPv6 and IPv4. As if you were running lots of, IPv6 hosts on your network and wanted to be able to find them. That became very chatty. It became something that people went in to try to turn off quite specifically. Any other questions? Any other topics I may have not covered? Everybody just came here fresh, newborn as a child, and you walk out here just mature and ready to take on the world. Is that correct? Everybody nods yes. Thank you. I appreciate it. For that, you can all go get cookies.